Hey everyone, so today we are going to be solving quadratic equations using the quadratic formula. So in order to do this, you have to know what the quadratic formula is. If you were taking the Regent, it would be given to you on the reference page. If you want to memorize it, the more you use it, the easier it's going to get. But you're definitely going to want to have this written somewhere or on your screen when you're solving these equations if you don't have this memorized. So I'm going to keep it right there. And they want us to solve this equation, 11p squared minus 17p minus 20 equals p squared. So the first thing that we need to do, just like if we were solving a quadratic equation by factoring, we need this side to be equal to 0. And in this case, it's equal to p squared, which we don't want. So we have to move that p squared first. So we are going to subtract p squared on both sides, and I'm going to subtract it from its like term, which is 11p squared. If you want, you can put the ones in front. Those cancel, and we subtract. 11p squared minus 1p squared gives us 10p squared. And then we have minus 17p minus 20 equals 0. Now, it's in standard form, and we're able to go ahead and use the quadratic formula. So in order to use the quadratic formula, you're going to see it has the letters A, B, and C in it. So we need to know what those letters are. So whatever's next to the p squared, that's what A is going to be. Whatever's next to the p, or if it doesn't have an exponent, or it has an exponent of 1, that's going to be your B value. And then your constant, which is just the number by itself, is always your C value. So I'm going to write it over here. A is equal to 10. B is equal to negative 17. You have to bring that negative with the 17. That subtraction sign needs to go with it. Now, same thing with that 20. C is equal to negative 20. We're going to take these three values and we're going to plug it into this formula. So let me just zoom out a little bit. Okay, so we have, let me just erase this. So x is equal to, we have a negative and then b squared. So I'm going to put in parentheses negative 17. So it says negative b. Our b is negative. You cannot leave that out. We have to have two negatives here then. Squared plus or minus. You're going to see how that comes into play in a little bit. Same thing, I'm going to put this negative 17 in parentheses. Squared minus 4 times a, which is 10, and c, which is negative 20. Extend this. All over 2 times a, which is 10. So a lot of numbers. I know it looks a little confusing. Just take it step by step. The next thing we're going to do is simplify what's inside the square root. So everything else I'm going to keep the same. Oh, I have a squared there and I don't need that. Sorry. That's just negative b. That's my mistake. Okay. So that's going to give us x equals. Now here, the only thing I'm going to do here is I'll multiply these and I'm going to multiply these. But I'm going to keep them where they are. A negative times a negative is a positive 17. I'm going to leave this blank for now. And this is all over 2 times 10, which is 20. Now, if you want to do this on in a separate area, because this can get a little messy, that's fine. So I'm going to do that over here. Just like finding the discriminant. Now, negative 17 squared. A negative times a negative is positive, so that gives us 289. And then I'm going to multiply all of these together. I'm going to treat this like a negative 4. So negative 4 times 10 times negative 20. That gives us a positive 800. When we add these together, we're going to get 1089. That's the number that goes inside our radical. So I would suggest taking this, doing it separately, then putting your final answer back into the square root symbol. Now, these are all going to be rational solutions. So that means that 1089 is a perfect square. So you can do the square root of 1089 and see what you get. So for now, I'm going to just do 17 plus or minus. Now the square root of 1089 is 33. So not the square root of 33, just the number 33. That's all going to go over 20. Okay, so all I did was simplify, and if you want to write that somewhere else, square root of 1089 is equal to 33. That's where that number came from. Okay, from there, this is where that plus or minus comes in. So it's 17 plus or minus 33. So I'm going to separate it. We have a plus and we have a minus. So 17 plus 33 over 20, and then 17 minus 33 over 20. 17 plus 33 is going to give us 50. So that's going to give us 50 over 20. And then 17 minus 33 gives us negative 16 over 20. We're almost done. All we need to do now is simplify these fractions. That's very, very important here. So for 50 over 20, a number that can go into both of these is 10. So you can divide both of these by 10. You're going to get 5 over 2. So x is equal to 5 over 2. That's one solution. And a number that can go into negative 16 and into 20 is 4. Divide both of these by 4. You're going to get negative 4 over 5. So x is equal to both of these. So a lot of steps, I know. Take it step by step. I'm going to just re-summarize what we did. I'm going to go back up here. So here's our quadratic formula. Like I said, write that down somewhere. You're going to need that. Get your equation to equal 0 first before you identify A, B, and C. If you don't do that, A, B, or C could be wrong. Then you know that A is going to be the number in front, B is going to be the number in front of the variable that doesn't have an exponent, and then C is just that number by itself. Make sure you bring negatives with you. Now you're going to take those values, plug them into the quadratic formula. Be aware of these negatives here. Same thing here. A negative times a negative has to give us a positive number. Then we multiplied these all together and simplified what was under the square root. That gave us 1089. The square root of 1089 is 33. We multiplied these, got positive 17 and 20. We were left with 17 plus or minus 33 over 20. Separated that out. Added and subtracted separately. Simplified our fractions, and those were our answers. So that is how you use the quadratic formula to solve quadratic equations. Good luck.